methods of separation in everyday life. Hello students, how are you all? I hope you all are doing well. So today in this chapter we will learn about methods of separation in everyday life. So students, in this chapter we will learn about how can we separate different things, what are the different methods to separate different things, okay, in our day-to-day life. So let's say we have a mixture of sand, then we have sand, and in it we have let's say some different kind of sand, right, containing stones, right. So how can we separate them? Sometimes we also see the salty water, right, in the oceans and in the sea. How can we separate them? So there are different methods of separation based on the kind of solution or kind of binding they have, right. So in this chapter we will learn about that. So let's get started. So we use many different substances like cereals, pulses, fruits and spices in our day-to-day life. Some of these can be used directly while others need some preparation. So for example, before cooking rice or pulses, we often remove some tiny stones and impurities. And this is because most of these items are mixtures containing different components while some are pure substances. So in our day-to-day lives, when we cook our food, right, we often first clean it and remove some impurities if it has some. Rice, for example, rice or pulses, when we cook them, we remove some small stones or some impurities that it has, right. So this is again, we are basically what? Separating the impurities. So let us first understand what are pure substance and mixture. So any substance exists in two forms, either in a pure state, right, either in a pure state or in a mixture. So pure substance can be elements or compounds, okay, and mixture can be homogeneous mixture and heterogeneous mixture, okay. So as we will progress, we will understand about all these terms. So let's first understand and begin with pure substances. So any material which is made up of only one kind of molecule is called a pure substance. So let's say this is a pen and this is made up of only plastic, right, and only plastic. So this will be called a pure substance, right. So any material which is made up of only one kind of molecule is called pure substance. So substance is said to be homogeneous if it consists of particles that are all the same, right. So when the particles are all same, homo means same, hetero means different. So when the particles are all same, it is called homogeneous. In other words, a homogeneous substance is that which has same chemical composition throughout, okay. Now the homogeneous means the substance which has same chemical composition. Let's say if I talk about water, the chemical composition of water is H2O, right. So if water has only the molecules of H2O, it will be called pure substance and the homogeneous, right, homogeneous water. So pure substance has some characteristic as given. So it has a definite melting point, right. So pure substance has a fixed melting point, okay. For example, melting point of ice is 0 degrees Celsius. So when when this water is pure, right, it is not any salt or sugar is not added to it. Pure substances have definite melting point, right. Now what else? It has a definite boiling point. So when the substance is pure, right, not added with any kind of other material, it has, for example, boiling point of water is 100 degrees Celsius, right. It has a uniform composition. So we talked about the homogeneity, right. Homogeneous means uniform compositions. All elements and compounds are pure substance. For example, gold and silver, right. These are what? These are elements, and these are in gold and silver are elements and in the pure form, because they contain only one kind of molecule, which is gold or silver, right. On the other hand, water and air are made of different kinds of molecules, right? On the other hand, water and air are made up of different kinds of molecules, so they are compound, right? So let's say water, okay? So water is what? Compound. Why? Because it is made up of hydrogen and oxygen, okay? Two different kinds of molecules. So they are called compound. Same goes for air, okay? Now we need pure substances for keeping our body healthy, using them in research work, okay? So when we do research work, we sometimes need the pure substance to do some experiments, making various useful articles like medicines with them. So we also need substances in pure form to make medicines, right? Now let's understand what is a mixture. So a mixture is a combination of two or more substances which retain all the properties of its components. Okay, so mixture is a combination of two or three substances. Okay, when added together, all the substances that are added retain their property. Okay, so for example, Nimbu Pani, or you can say lemonade, right? It is a mixture of what? The lemon juice, sugar and water. So when we drink lemonade, we also get sugary taste. It also retains the property of water and it also tastes like lemon, right? Same goes with tea. Tea is a mixture of water, milk, tea, leaves and sugar, right? And when we drink tea, we also are drinking water, right? It has a property of water also. It will show the property of milk also, tea leaves also and sugar also. Tap water is a mixture that contains many dissolved salts. Air which surrounds us is also a mixture of various gases, dust, smoke and water vapor. So mostly the things that we see around is a mixture of different things. Now let's go to the next page. So let's explore and do one experiment to understand how Nimbu Pani, lemonade, is a mixture and observe how its ingredients combine. So collect lemon juice, water and sugar and then mix them in a jug until the sugar dissolves completely. Okay. Now observe, watch how the lemon juice, water and sugar blend together to form a Nimbu Pani. So when you drink Nimbu Pani, right, you get distinct taste of Nimbu, the lemon and the sugar, right? So yet they are together, right? Yet they are blended together. Now notice how the lemon juice and sugar mix evenly with water, creating a uniform solution. So on this, so when we look at this lemonade solution, we don't see sugar or lemon as a separate entity floating in them, right? We see a complete one solution. Okay, so this is a uniform solution. Now the mixture is clear and you can taste the combined flavor of lemon and sugar in drink, right? So when this solution is ready, this forms a mixture which is clear and it gives a combined flavor of all the things added to it. So this means that the Nimbu Pani is a mixture because it combines lemon juice, water and sugar without forming a new substance, right? So when we added all the substance in it into water, right? We added lemon and we added the sugar. It didn't get converted into something else, right? But it only dissolved, right? So the ingredients retain their individual properties but mix together to make a refreshing drink, right? So they have retained their properties. Now what are the types of mixtures? So mixture may be heterogeneous or homogeneous. So what is homogeneous mixture? The components of many mixtures such as air, milk, seawater and sharbat cannot be seen separately. So when we see a mixture such as air or let's say milk, right? Can you add water to milk? Yes, we can add, but can we separate or can we see the layer of water and milk separately? No, right? And so such mixtures appear to contain only one substance, right? When we add water to milk, it appears, the whole solution appears like a milk. But actually they contain many substances which cannot be separated easily, right? So once water added to the milk, it cannot be separated easily. So such mixtures are called homogeneous mixtures, right? Now what are heterogeneous mixtures? So sometimes substance present in a mixture can be seen very easily, and such mixtures are said to be heterogeneous mixture. Hetero means different. For example, the yellowish sulfur powder can easily be seen in a mixture of iron powder and sulfur. So when you add yellowish sulfur powder with the iron powder and sulfur, you will easily see the sulfur powder differently. Okay. Moreover, both the components iron and sulfur retain their individual properties in the mixture and can easily be separated by using a magnet. So see, even if they are mixed together to form a mixture, they are retaining their properties, right? But in case of heterogeneous mixture, they are not binding together, they are not blending together, right? They can be seen differently very easily. Now, why to separate mixture, right? We just now learnt about mixture, right? But why we need to separate mixture, right? What's the use? What's the need? So we have learned that a mixture contains two or more kinds of substance, so they need to be separated before use. So since a mixture has two or more kind of substance, if you would like to use any of those substance, you would need to separate it, right? And therefore there is a need to understand how we can separate different kind of mixtures, because there are different methods to separate homogeneous mixtures and heterogeneous mixtures. So separation is the process of removing unwanted or harmful components from a mixture to get desired component for use. So when we separate things, we are basically removing unwanted things, right? For example, when I separate the small stones from the rice, basically I am removing the unwanted stones, harmful components from the rice, the mixture of those. Okay. So we separate components of a mixture by various methods. First is to remove unwanted components. So first of all, it is necessary to remove unwanted components of the mixture. Sometimes we can see tiny stones present in rice. It is necessary to remove them before cooking as they are harmful for our body. We all know that we always remove tea leaves from prepared tea by using a strainer to get pure form of tea. So when we want to drink or utilize that mixture, right, we remove the unwanted components. For example, we remove tea leaves from the tea, we remove stones from the rice and pulses, right? Sometimes there are some kernels, right, that are there in the rice and the pulses. We remove those. So we remove the unwanted components from the mixture. Next, what? To remove harmful components. Why do we separate things? Because to remove unwanted components, to remove harmful components. Now we all know that harmful substances are present in river or lake water. They must be removed before using water. So we always filter the water supplied to our homes to remove harmful substances. Now see, the water that we drink, right, it is coming from the lakes, the water bodies, right, different water bodies. So they also need to be separated because they have harmful components also, and harmful components needs to be separated from the mixture of water and different minerals or salt, right, through filtration. Now to get useful substance. And the third reason and the main reason why we are separating a mixture, to get useful components. So sometimes we separate the components of a mixture to get the useful substance. So for example, we separate butter from curd by churning it, right? Sometimes we separate mixtures to only get the useful components, right? For example, when we talk about the butter, right, how do we get it? We get it from churning the curd, right? So curd is a mixture of water, right? It has butter also, right? So when we churn it, we get the butter, right? Now let's go to the next page. We also get some useful liquid fuels like petrol, kerosene and diesel by separating them from crude petroleum. So again, now can you see this, that it is a liquid, that petroleum, right, it is a mixture of many things, and we separate useful fuels like petrol, kerosene out of it. Now other point is to get a pure sample of a substance. So we also separate mixtures, right? We also separate different substances from a mixture to get a pure sample of a substance. So sometimes we separate the substance from a mixture to get a pure substance. Pure substance are needed in research, medicines and at our homes for daily use. So see, when we want to make medicine or we want to do some research, we want to conduct some experiment, we need the pure substance, right? And for that we need to separate it from the mixture, okay, in the pure form. So students, do you know about this scientist Praful Chandra? Okay, so Praful Chandra Ray, known as the father of Indian chemistry, founded Bengal Chemicals, India's first pharmaceutical company. He discovered merasmus nitrate and encouraged scientific research and education, inspiring many Indian scientists to contribute to the growth of chemistry in India. So he was Indian scientist Praful Chandra Ray, and he basically the first pharmaceutical company, he found that company Bengal Chemicals, right? He also discovered merasmus nitrate, right, which encouraged more scientific research, more discoveries like this in India. Okay, now let's understand what are these methods of separation. So we discussed about the need of separation, right? Now let's understand the methods of separation. So method of separation of components of a mixture depends on the difference in the properties of various components. So see, the kind of component a mixture has, that will decide the type of method we will use. So the various methods of separating components of a mixture are discussed here. So let's see one by one. So first is hand picking. So this is the most very simple process, the process of separating manually, right? We use hands. So the solid components of a mixture which differ in their size, color or shape is called hand picking. See, as you can see in the picture also, that lady is basically using her hand to pick out some components that are of different size, that may be of different color or shape from the grains, right? So this is called hand picking. Now you have to now the main thing here is that the component that is removed from the sack, from the grains, are what? Are basically, they differ in their size, the color or the shape, okay? So these are something that can be seen easily, okay? Now in this method, separation is based on the difference in color, basically their physical property like the color, size or shape of the components of the mixture. So this method is useful only when one of the components of the mixture is present in small quantity, okay? So this method is useful when the component is basically present in small quantity. Second, when the component can be physically seen, okay, physically different from the other components. So this method is used in homes to remove impurities from food items like wheat, rice and pulses. So if we talk about the impurities that we take out from, let's say, wheat, rice or pulses, what kind of impurities do you see? We see stones, right? We see some straw, right? So they are very different from the rice, pulses or the grain we are separating it from, right? They differ in size, they differ in the texture also, and they differ also in the color. So this is how this method is useful in case of food items. Now other method is threshing. Grain seeds are separated from their stalks by the method called threshing, and in this process the stalks containing grain seeds are beaten on a hard and rough surface so that the grain seeds get separated from the stalks. So have you ever seen a mustard stalk? Okay, so in that there are very small seed coats in which mustard is present, okay? So to remove the mustard from its coat, what they do, they use this method of threshing, okay? So they beat the stalk, okay, hard enough on a surface so that the grain of that seed, Okay, so the seed and that stalk separates. Now sometimes bullocks are also made to walk on stalks spread across the ground, and grain seeds are thus separated from the stalks. So sometimes, now see what is happening here, you are applying the pressure on it, okay, so that the grain and the stalk get separated. Sometimes this pressure is applied through what? By making bullocks to walk on it, right? This makes the grain and the stalk get separated from each other. These days threshing is usually done by a machine called thresher. Earlier it was done by humans, but nowadays it is done using a machine known as thresher. Okay. Now students, the third technique is winnowing. So separating the lighter components of a solid mixture by blowing through wind is called winnowing. So sometimes what happens is, with grain there are a kernel of seed also comes with that seed, okay, and if we compare the weight, the kernel of the seed, or you can say the seed coat, is quite lighter from the seed, right? So to remove that kind of mixture we use winnowing, right? So it use the wind. This method of separation is based on the difference in the density of the components. So farmers separate grains from the husk by winnowing, right? So husk is quite lighter as compared to the grains, okay, and that's the reason they use this process called winnowing. They allow the mixture of grains and husk to fall from a height. So this is how winnowing is done. The farmer throw their mixture of grains and husk from a height, and as it comes down, as it falls, the husk moves away from the wind, right? And this is how only the grain drops there, okay? So this is how the winnowing is performed. Now let's go to the next page. So the husk being lighter is carried away by the wind, while grains being heavier fall vertically downwards. The husk gets collected at a shorter distance from the heap of grains. Thus grains and husk are obtained in two separate heaps. So see, when the husk and the mixture of husk and the grain, when falls from a height, husk being lighter, they fall apart, right, due to the wind, and lighter, the grain being lighter, they fall downwards, right, and this leads to the separation of separation of grains and the husk, okay. Now the fifth method is sieving, right? So this method is based on the difference in the particle size of the components of a mixture. So when a mixture has different components that has different particle size, okay, then this method is used. So separating the components of small particles from those of a bigger ones by passing the mixture through a sieve. So sieve is an apparatus having holes in it. It is called sieving, right? So basically sieving is what? We want to separate one kind of particle, right? What are those one kind of particle? So let's say there is one mixture in which two components are present, one are of this size and one is of smaller size, right? When we will use this method to separate this mixture, what will happen? This component will be differentiated by what? By this apparatus, right? And this component of smaller size will fall downwards, right? So this is how this process happens. Now let's do an activity to know how sieving method separates mixture. So what you have to do is take some wheat grains and mixed with fine clay powder in a sieve, okay? So take some wheat grains. Now see, wheat grains is proper wheat, okay? So these grains are bigger in size than the clay powder here. Now put that in a sieve. Now move the sieve to and fro repeatedly. When you will move this, what you will see, that the clay particle will sieve down, okay, and in the sieve only the grains will remain. Now you will observe that fine clay particles being smaller in size pass through the holes of the sieve and fall down, but the wheat grain being bigger in size are left behind the sieve, right? Now what this experiment tells us, the mixture being solid, components of the different size can be separated by sieving, right? So when the mixture have different solid components of different size, it can be separated by sieving. Now students, some other examples showing separation of components of mixture by sieving are like wheat bran is separated from wheat flour by this method. So wheat bran is what? The outer covering of the wheat, okay? So we separate wheat bran from the flour by sieving method, right? We use this method in our day-to-day lives. Fine sand can also be separated from gravel by this method. So when the mixture of gravel and sand, when separated using sieving, fine sand is sieved down and the gravel is there in the sieve. Now jewelers separate pearls of different sizes by sieving. Okay, so jewelers also use this. So can you just see that this method is used by different industries, right? It is used in agricultural practices, it is used by jewelers also, it is used in pharmaceutical companies also, okay? Now at construction sites also this is used. So sand is separated from stones using a sieve with bigger holes. So here in all these situations, the sieve they are using depends upon the particle size, okay? Now here the sieve will have bigger holes, okay? Now let's talk about magnetic separation. So this is another method. So the components of mixture that contains magnetic and non-magnetic substances can be separated by using a magnet of suitable size. For example, a mixture of iron fillings and sulfur can be separated by using a magnet. So in this method, students, of magnetic separation, we separate mixture which contain some component that is attracting towards magnet, right? And it has some component that is non-magnetic substance. So for example, a mixture of iron fillings and sulfur, right? So iron fillings being the thing that can attract magnet, right? And sulfur being non-magnetic substance. So these can be separated using this method. Now in many industries, large electromagnets fitted to a crane are used to separate scrap iron from waste material. It is done in order to collect iron for recycling and hence to minimize waste. So in industries where where the iron from the scrap is separated from the waste material, this method is very common and very useful, because it reduces the time, it reduces the effort and do the job, okay? Thus, magnetic separation can be defined as a process of separating magnetic components such as articles made up of iron, nickel and cobalt from non-magnetic components of a mixture by using a magnet. So what is magnetic separation? It is a separation of magnetic components from the non-magnetic components, using magnet, okay? So the method of magnetic separation is based on the fact that magnetic substance get attracted towards the magnet. So what's the catch here? What is the catch here? So in this process, magnet is used, right? And magnet attracts the magnetic substance, like what? Like the iron, nickel and cobalt, okay? Now let's do one activity to separate the components of the mixture of sulfur and iron filling. Now here iron filling is what? It will be attracted by the magnet. So we will need take a mixture of sulfur and iron fillings, spread it on a wide pan. Now take a magnet and move it through the mixture, okay? So what you have to do is take a wide pan, pour the mixture of sulfur and iron filling and move the magnet above it. Now let's go to the next page. So now here you will see that the iron fillings stick to the magnet, okay? Why? Because iron fillings are attracted towards the magnet because they are made up of iron, right? Now they are magnetic substances. Now remove these iron fillings and again move the magnet through the mixture to separate out iron fillings from it. So from this experiment we understood that after some time the iron fillings will get completely separated from the mixture, leaving behind yellowish sulfur only. Okay, so this is how we can separate magnetic and non-magnetic substances. Now there is another method, which is sedimentation and decantation. Now the substances that are heavy but insoluble in water can be separated by sedimentation and decantation. So such a mixture which have components which are of different density, right? One is heavy, one is lighter, right? In those kind of mixtures, they can be separated through sedimentation and decantation. Also, one more thing is important, they should be insoluble, right? They should be insoluble. Now the process in which heavier particle of an insoluble solid in a liquid settle down at the bottom of the container is called sedimentation, and the particles that settle down are called sediment. Now what is sedimentation? When the heavier particle from the mixture, and they are what? Insoluble. So when the insoluble solid from a mixture settles down at the bottom of that container, right? This process is called sedimentation, right? Why they are settling down? They are settling down, one, because they are heavy, second, because the gravity is acting on them, right? Now third, also because they are insoluble, right? They are not soluble. That's the reason they are settling down. Now these solid substances are called sediment. When the sediment settles down, a clear liquid forms the upper layer. This can be poured in another container without disturbing the sediment. So once the sediment, that solid part has settled down at the bottom of the surface, now we have left with what? The liquid from the upper layer. Now this liquid can be easily poured, can be easily transferred to the another container without disturbing it, and this process is called decantation. So what is decantation? The process of separating the upper clear liquid from a mixture of heavy insoluble solid particle in the liquid is called decantation, right? It is basically removal of it is basically the last step of this separation. We are separating the solid insoluble part from the liquid. Now let's do one activity to understand this. So to separate sand and water from the mixture by sedimentation and decantation, we know that sand doesn't get soluble with water, right? It is insoluble. Okay, now we so take a mixture of sand and water in a beaker, keep the beaker undisturbed for some time. So when you will take a mixture of sand and water and keep it aside for some time, you will see that after some time the sand particles will get settled at the bottom of this container, right? And on the top of that the layer of water will be formed. Okay, so you will see that sand particles, being heavy and insoluble in water, settle down at the bottom of the beaker. Okay, now pour the upper clear water into another beaker. Slowly but carefully, with the help of glass rod, the sand particles will be left behind in the first beaker, right? So now you can, after it gets settled down, you can decant it, right? We studied about this process. We can do this. This shows that the sand particles settle at the bottom of the container, right? Now students, in our homes, pulses and rice etc. are first washed with water, and then water is separated by decantation, right? So you can also see this process, this physical method of separation, that is sedimentation and decantation, in your day-to-day life. Okay, now there is another method, which is separating funnel. So we can also separate the components of a mixture containing two immiscible liquids using separating funnel. Now let us perform an activity to understand this concept more clearly. So first of all, let's first understand what is this two immiscible liquid. Immiscible liquids are those liquid which are liquids but they don't mix with each other, right? For example, water and oil, they don't mix with each other, but they both are what? Liquids, right? So in those type of mixtures, separating funnel can be used. So let's do this activity to understand this process. So to separate the components of a mixture containing two immiscible liquids, what we have to do is take a separating funnel and fit it in a stand as shown in this figure. So this is how a separating funnel looks like. Okay, this is the place where you pour the solution, pour the mixture, and this is the tube where from where the mixture, the separated mixture will come out. Now pour a mixture of water and kerosene into the funnel. Allow it to stand and undisturbed for some time. So put the mixture of kerosene oil and water here. Okay, and then let it undisturbed for some times. You will see that the water and kerosene oil will form a separate layer after some time automatically. So after you will see that water being heavy occupies the lower portion of the funnel, while the kerosene being lighter occupies its upper portion. Alright. Now let's go to the next page. So now keep a clean beaker below the separating funnel and open the stop cork of the funnel. Water starts flowing down into the beaker. Now see, these kerosene and water have separated into two layers, right? Now we are separating them. How? By this method. We will open the stop cork, okay? We will remove the stop cork and let the water flow from the funnel down into the beaker. Now close the stop cork of the funnel as soon as the line separating the two liquid reaches the hole of the stop cork, okay? So here you have to be very quick. You have to stop the cork where the line of the kerosene will start, okay? Now kerosene left behind in the separating funnel can be transferred into another beaker. So this is how the separation of two immiscible liquid can be done. So this activity showed us that immiscible liquids can be separated by separating funnel, right? Now there is another method which is loading. So sometimes sedimentation takes a very long time. Why? Because it is first dependent upon the size of the solid particle, okay? And second, it is also dependent upon the gravity, right? This happens when the suspended particle of a solid in a liquid are very fine. So generally what happens is when there is a mixture of solid and liquid, right? When insoluble solid is mixed with liquid, right? For example, sand and water. So this can be easily done with sedimentation and decantation. But in this case, when the solid particles is very thin, right? This process is used, right? Because then in that case, sedimentation will take a very long time. The method that is used to speed up sedimentation by making the particle heavy is called loading. So basically, to make the sedimentation process quicker, right? This method, that is loading, is used, okay? So what it will do, it will make those particle, very fine particle, heavier, okay? Increasing the speed of sedimentation. Now this process is based on the fact that the small suspended particle can be made bigger and heavier. So let's say this is the container with sand and water, right? So these are very fine particles, right? These are fine particles. Now through this method, through this loading method, what are they doing? They are basically making it heavier, right? Making it bigger and heavier. So they load it and make it heavy and big. Alright. Now for example, some alum dissolves in water and its particles join with the clay particle and make them heavy. So alum is used as a load, right? Alum dissolves in water, it joins it with the clay particles, okay, and then make it heavy and bigger. So as a result, clay particles settle down very soon, making the rest of the water clear. This clear water can easily be decanted in a separate beaker. So by adding alum, right, the speed of sedimentation can be increased and then the rest of the process can be followed up. Now dust particles in the air settle down after the first rain. So the air after the first rain is comparatively clean. This is exactly what happens in case of rain also, right? When there is a dust particle in air, right, dust particles are very fine particles. Now when the first rain happens, what exactly is happening? The water droplets combine with those fine particles and makes that heavier and bigger, making the dust particles to come towards the land, right? And this is the reason after the first rain, the sky and the air becomes cleaner. Now there is another process which is filtration, but before this let's do one activity to understand this loading process. So to load the light suspended particle of a mixture and hence to make them heavy. So what you have to do is take some muddy pond water in a beaker and you will see many fine clay particles suspended in it. So if you take some muddy water, pond water, where you see the standing water, you will find the sand of that kind of water has very small fine particles. Okay, now this kind of pond water is very good fit for this kind of experiment. Now take a big piece of alum, okay, or you can also, this is called fitkari in Hindi, right, and put that in water and suspend it by a thread. Move it throughout the muddy water. Now you will observe that you will find that suspended clay particles settle down at the bottom of the beaker, right, very soon, and this process is called loading, right. So what happened when we added alum? It attached itself with the fine particles, making it bigger and heavier, leading to increased sedimentation rate. Now this tells us that loading helps to speed up sedimentation. Now let's come back to the other method, which is filtration. So in our homes we separate tea leaves from prepared tea by using a strainer. The tea leaves are left behind in the strainer and the liquid flows out. Okay, so this is called filtration, when a sieve is used to separate a liquid, right. Now this process that we used here to separate liquid tea from solid tea is called filtration, right. So here liquid tea, basically a liquid is filtered from the solid, right, and this is called filtration. Now the strainer acts as a filter. Filtration can be defined as the process of separating the insoluble components of a mixture by passing it through a perforated membrane or a filter paper. Okay, so basically here filter is used to filter that mixture where the liquid or the insoluble component of a mixture is passed through that strainer and then separated out. Now filtration is based on the fact that insoluble component of a mixture cannot pass through the fine holes of a perforated layer of filter. So here what is happening, while we pass the mixture from the filter, only the insoluble component of that mixture remains on the filter and the rest other thing will pass through that filter. Okay, so this is how on this method, this filtration method works. Do you know, students, apart from filter paper, materials like cotton, charcoal and sand can also be used for filtering. The type of filter chosen depends on the size of the particle that needs to be removed. So the type of filter paper, we have different kind of filter paper and other materials can also be used like cotton, charcoal and sand. So the size of the particle that we have in our mixture, that decides the size of our filter. Okay. Now students, let's get to the next page. So there is one more activity to understand, to separate the components of a mixture of sand and water by filtration. So we can separate the mixture of sand and water by sedimentation and decantation, but also by this process. Let's see how. So take a round piece of filter paper, fold it twice and make a cone as shown in this figure. So take this filter paper, okay, so filter paper comes in this shape in schools and in laboratories. Fold it and make a cone, right. Now place this cone inside a glass funnel, okay. So take this glass funnel and put this cone inside it, the filter paper, okay. Now place a clean glass beaker below the funnel to collect the separated liquid, okay. Now pour the solution of water and sand into the filter cone using a glass rod. So whatever mixture you have, pour that into the funnel having the filter paper, right, and then slowly you will see that the beaker is filling with some liquid, the water. Now clear water will trickle down into the beaker and the sand will be left behind in the filter cone, right. So you will see that the water is slowly dipped down into the beaker and will be collected into the beaker, and the remain, basically what the sand will be strained in the funnel. Now this wet sand can be dried by pressing it and between the folds of the filter paper. This sand can, to get sand in a more dried form, it can be pressed and dried in the sun. So this tells us that insoluble impurities, like in this case the sand, can be separated by filtration method. Now students, there is one more process called churning. Okay. So the process that involves vigorously stirring or agitating a substance to mix it or separate its components, it is termed as churning. So what is churning? It is the process, it is a physical method where the substance are vigorously stirred, right, vigorously agitated to separate different components out of it. Now people in villages especially mostly use churning to separate butter from the buttermilk, right. So the buttermilk or sometimes curd is churned, right, it is agitated again and again to get the butter out of it. So this involves stirring cream to separate the solid butter from the liquid buttermilk, right. Now churning is not limited to butter only. Okay, this is just one example. It is not just limited to butter, it is also used in making homemade ice cream by continuously stirring the mixture to achieve a smooth texture, right. This is also done to in industries also to make ice creams, right. Now it can help mix soil with compost in agriculture, improving soil quality to better plant growth. Now we can also mix compost in our soils, right, with this method, and this will make our soil even more richer. This technique effectively blends or separate materials in various applications. Now there is another method called evaporation. Till now all the methods included physical separation, right. Now comes the evaporation. This is the process in which a liquid changes into its vapor form on heating in a funnel is called evaporation. So when the liquid changes its form to water vapor, that is called evaporation. And the method of evaporation is used to separate soluble components from a mixture in a liquid. Now when there is something that has dissolved in the liquid, like for example seawater or the ocean water has dissolved salt in it, right. So in that case evaporation works, alright. Now the dissolved soluble component of in the water, that is the salt, is separated from the liquid through this method. The mixture is heated till the whole of its liquid component vaporizes. So let's say we have a liquid, we will heat it until all the liquid gets evaporated, leaving only the salt behind it, right, the soluble component behind it. So let's do one activity to understand this process. So to obtain salt from the salt solution by the method of evaporation, what you have to do is take some water in a beaker. Okay, so we have a mixture, we have a solution of water and salt, right, and make sure you put up this setup, right, put this spirit lamp and burn it, right. Provide a heat this solution until it starts to vaporize. Now let's go to the next page. So add to it some common salt, okay, add to the liquid some common salt. To remove the insoluble impurities, filter this solution with the help of piece of filter paper. So if that solution has some insoluble impurities, you can use the filter paper. Now take the filtered solution in a china dish. Place the dish on a stand and heat it from below. Now when you will heat it, what will happen? After some time students, you will notice that water of the solution will go up in the air as steam, right? It will all evaporate and will be converted into the steam or the water vapor, leaving behind common salt as a residue in the china dish. So what will remain? The salt only. So this shows that salt can be obtained from salt solution by evaporation, right? Common salt is obtained from the seawater by this method only. So seawater is taken into shallow trenches exposed to the sun. Okay, so shallow trenches are made and they are exposed to the sunlight. Okay, so through the sunlight, when the water evaporates into the air as vapors, what happens? The salt crystal are left behind, leaving behind salt crystal in the trenches. Okay, so this is how salt is obtained from the seawater. Now students, let's do one more activity to observe the effect of evaporation on salt solution. Let's see how the evaporation affects the salt solution. Now dissolve 2 to 3 tablespoons of salt in half a bowl of water. Now spread a few drops of solution on dark paper and let it dry. Okay, so when you will put this salt solution on a dark paper and will left it to dry, you will see that we know that the salt is of what? White color, right? So if you have placed the black color, right, we will after the evaporation we will be left with only salt, right, which means that we will see some whitish thing, white spot on the black paper, right? So let's see what we will observe. After drying, white salt patches will be appear on the paper, right, and the water has evaporated, leaving this salt behind. Okay, so this is the effect of evaporation on that salt solution. This shows that the salt remains on the paper after evaporation, showing how dissolved substances are left after the water evaporates. Okay, so once after the evaporation, the dissolved substance are left behind. Another method is condensation. So the process of changing water vapor into liquid state on cooling is called condensation. So when water vapor changes into what? The liquid water. Liquid. It is called condensation, and this happens when on cooling. Okay, so when lower temperatures are provided, and this process is just opposite to evaporation. In evaporation, the liquid was converted to water vapor, right, by providing heat. Now the reverse is happening. So we can separate a liquid from a salt solution by this process. Okay, now let's do this activity to separate water from the salt solution. Okay, so till now we understood that we can separate the soluble part, that is the salt, from the salt solution, but we can also separate the water from the salt solution. Let's see how. So pour the common salt solution in the aluminium kettle and close it with the lid. Okay, so we have a salt solution in this kettle, right? Now place a tripod stand on a gas burner. Okay, and now place the kettle on this tripod stand by keeping a wire gauze below it. So basically we have to heat it. Okay, we have to heat the kettle. We have to heat that salt solution. Heat the kettle till the steam comes out freely from its mouth. So we have to heat till the water gets converted into the steam and it starts to come out, right? Now see, what we have to do is place a few ice cubes in frying pan and hold it in slanting position. Okay, so what we have to do is we have to place a frying pan like this, or you can also place some plate also, right, just in at some distance. So what will happen? Water condenses to form droplets of water on the underside of the frying pan or the plate. So this frying pan, the surface of the frying pan or the plate that we'll put will provide the cooling temperature, right, will provide the lower temperature than the kettle. This will allow the condensation of water droplets into the water. Now these droplets of water trickle down the side of the pan and then start to fall down. So here you will get the condensed water, right? So now can you see, we can also separate out water from the salt solution. So in this experiment we observe that when drops condenses when come in contact with the surface, right, when the stem came in the contact with the frying pan, right, it condensed, right, in the form of water. So this tells us that water vapor can condense on cooling, right? Then we have one more method, it is called distillation. So a process of changing a liquid into vapor and then condensing it into pure liquid is called distillation. So basically what is happening here, a process of changing a liquid into vapor and then condensing it into pure liquid is known as distillation. So student, what happens in distillation is that the liquid is converted into water vapor and then this is condensed into pure liquid. Okay. So this whole process is called distillation. Now in this process, evaporation and condensation go on side by side, right? So so you will see that the process that we studied right now, evaporation and condensation, distillation is the mixture of both of these processes. Now let's go to the next page. So in this method, solution which is a mixture of soluble liquid, soluble solid in a liquid. So let's say the salt solution, okay, is heated in a vessel to convert its liquid into vapor, which is collected and cooled in another clean vessel. Soluble solid is left behind in the first vessel. So what are they doing? They are basically heating the mixture of soluble liquid in soluble solid in a liquid, which means that we have soluble solid as salt as soluble solid and water as liquid, okay. So when they are mixed, we get a solution of what? The salt solution, right? Now this salt solution is heated in one vessel to convert its solution into a vapor, right? Then these vapors are then collected into another vessel, right, after cooling, right? Now soluble solid is left behind, which is the salt in the first vessel. So this is how this process is done. Now distilled water used in laboratories is obtained by this method, okay. So this method is the purest form of water, right, and this is used in laboratories. Impure water, that is water containing dissolved salt, is taken in a flask which is fitted in a stand. Now the water that we have is a impure water because it contains a lot of different kind of salts, right? Now this water is taken and it is poured in a flask which is fitted in a stand. Now an apparatus to cool the water vapor called the Liebig's condenser is fitted to this flask, okay. So this is how this process is done. Now we have another method which is crystallization. So crystallization is what? A process of separating a pure substance in the form of crystals from its hot concentrated solution by cooling is termed as crystallization. So in crystallization, the pure substance is separated in the form of crystals, right? We are left behind with the crystals. Now the process of crystallization is used to obtain a pure sample of soluble solid liquid, and in this method the maximum amount of given powdered impure solid is dissolved in a hot liquid. So this soluble solid liquid is first dissolved in the hot liquid. Now the solution so formed is filtered to remove its impurities. Now it is first filtered, right, to remove the physical impurities. On cooling, when we cool this hot liquid solution, the filtrate gives us crystals of the pure solid. So when it cools down, the filtrate which is filtered results in the crystals, okay, as a pure solid. Now let's do this activity to get pure crystals of copper sulfate from the impure sample. So what we have to do is take some pure water in a china dish, heat it to a definite temperature, okay. So take some water, heat it. Now add to it given powdered impure copper sulfate pinch by pinch and stir it with a glass rod. So pinch by pinch slowly add the mixture of the impure copper sulfate, okay, to this hot liquid. Now repeat this process till the solid stops dissolving. Okay, so keep adding that mixture till it stops dissolving any more sulfate, copper sulfate. Okay, now filter this hot solution, collect the filter in a beaker and allow it to cool down. Okay, so filter it and allow this to cool down. After this, you will see on cooling, crystals of pure copper sulfate can be separated, right? So this method tells us that crystals of copper sulfate can be obtained by the process called crystallization. Now we have another process called sublimation. So the process of changing a solid directly into the vapor on heating and vapors into solid on cooling without going into the liquid state is called sublimation. So see, sublimation can be represented like this. So what we are doing, we are converting solid directly into the vapor, right, by heating it, and then we are converting vapor by cooling it directly into the solid. So here we are escaping what? The liquid state, right? And this process is called sublimation. Now this method is used to separate the components of a mixture of a sublimable substance and a non-sublimable substance. Now when we have a mixture of substance, when we have a mixture where one substance is sublimable, right, and other is non-sublimable, right? For example, common substance which sublime on heating are like ammonium chloride, naphthalene, camphor and iodine, right? When we burn camphor, it is in solid state, right? It directly turn into vapor, right? It is not converted to any liquid state. So this is called the sublimation, right? Now thus it is clear that ammonium chloride, naphthalene, camphor and iodine can be separated from a mixture by the process of sublimation, right? Now we have one more method called centrifugation. So the process of separating suspended particles of a substance in a liquid by rotating it rapidly is called centrifugation. So centrifugation is the process of basically separating different size particles, right? And the main thing is we are rotating this mixture with a very high speed, right? This creates the suspended particle, the heavy particles suspend to the bottom of that beaker. Now centrifugation, this method is done using a machine called centrifuge or the centrifugal machine, and these machines are generally used in the science labs or in the industries. Now let's go to the next page. So this is how this centrifuge machine looks like. Okay, so here these test tubes are placed. Okay, closed tubes are placed, right, and then it is closed and then rotated at a very high speed, right? This results in that sedimentation process, right? Now during the process of sedimentation, a mixture of fine suspended particle in a liquid is taken at a test tube. This test tube is placed in a centrifuge machine and rotated rapidly for some time. As the mixture rotates rapidly, a force acts on the heavier suspended particle. So as it rotates, right, the force, the centrifugal force, right, acts on the heavier suspended particle in it and brings them down at the bottom of the test tube. Okay. Now the clear liquid, being lighter, remains on the top of the test tube. Okay. Now this method of centrifugation is also used for separation of cream from the milk. Okay. So this method is also used in industries where the cream is separated from the milk, right? In this method, the milk is put in a closed container in a big centrifuge, where as soon as the centrifuge is switched on, the milk starts rotating at a very high speed. As a result, the cream of the skimmed milk are separated. The cream, being lighter, floats over the skimmed milk, which can be easily removed, right? So this method is not just used in the laboratories but also in dairies, right, where cream is separated from milk. When in container milk is poured and it is given a good amount of rotation, right, the centrifugal force makes the particles of the cream being lighter floats over the skimmed milk, which can be easily removed. So this method of centrifugation is not just used in the scientific laboratories, but is also used in dairies to separate cream from the milk, right. Now, separation of mixture by using a combination of method. So, a mixture can also be separated using a combination of methods. Till now, we have studied different kind of methods. Some are physical methods, some are chemical methods, some are, like for example, centrifuge is a physical method, right, where centrifugal force is used. Now, some mixtures can be separated using 2 or 3 of these methods together. Now, let's see how. So, sometimes a mixture contain more than one component which cannot be separated using a single method, right, and for this purpose a combination of method of separation is used. Sometimes we have such a component in our mixture where it cannot be separated by using just one method, right, and so to separate it we need to use more methods. So, to understand this concept clearly, let us consider some mixtures containing more than 2 components. So, let us understand these 2 from examples. So, separation of components of mixtures containing sand, iron fillings and ammonium chloride. So, let us say we have a mixture of what? Sand, iron fillings and ammonium chloride, and we will first separate iron fillings from the mixture of by magnetic separation. So, we know that we have the iron fillings can easily be separated through the magnetic separation, right, it will attract to the magnet. So, first of all what we will do, we will use magnetic separation technique to remove iron fillings from it, right. Now, iron fillings have been removed, we are left with sand and ammonium chloride. Then ammonium chloride and salt are separated by the method of sublimation, right. Now, we can use the sublimation process to separate out what? The sand and the ammonium chloride. Similarly, separation of the components of a mixture containing sand, water and mustard oil, right. So, if we want to separate all these 3 things, we will first filter the mixture of sand, right, water and mustard oil. Since sand is insoluble in water as well as in mustard oil, it will be left in the filter paper as residue, right. Since if we see in sand, water and mustard oil, sand is something which is not soluble, right, neither in the water and nor in the mustard oil, right. So, we will first separate the soil from this solution. Now, after this is separated from using filter paper, water and mustard oil will be collected as filtrate. So, now we are left with what? Mustard oil and water. Now, what we will do? Now, we will put the filtrate containing water and mustard oil in a separating funnel. Water being heavy forms the lower layer and mustard oil forms the upper layer. We also know that water and oil doesn't mix, right. So, now they will form the different layer. So, water being the heavy, it will go towards downside, right, and mustard oil being lighter than the water, it will be separated in a upper layer. So, the lower layer of water is run out first by opening the stopcock of the separating funnel. Mustard oil remain behind the separating funnel, which is collected in another container, right. So, once these 2 layers have been formed, the lower one being the water and upper one being the mustard oil, we can open the funnel, right, open the cork of the funnel, right, and then carefully close the cork once all the water has been removed from this funnel, right. Now, let us go to the next page. Now, we have read new words in this chapter, so let us recall this. So, pure substance. It is a homogeneous substance made up of only one kind of molecules. What is mixture? A combination of 2 or more pure substances which retain all the properties of its component. Winnowing. Separating the lighter component of a mixture by blowing wind. Loading. Method of speeding up sedimentation by making the particle of an insoluble solid heavier. Now, filtration. Separating an insoluble component of a mixture by passing it through a porous partition. What is evaporation? change of liquid into its vapor on heating. Crystallization, process of separating a pure substance in the form of crystals from its solution. Sublimation, change of solid directly into its vapor on heating without going into a liquid state. Now let's get to the main points of this chapter. So, a homogeneous substance which is made up of only one kind of molecule is called a pure substance. Okay. Purity of a substance can be tested by finding out its melting point or boiling point, which remains fixed for each pure substance. We need pure substance to keep our body healthy, use them in research, make some useful articles. Okay. A combination of two or more pure substance which retains all the properties of its component is called a mixture. We see many mixture in our daily life such as air, milk, soil, juices, river water and pond water. We separate components of a mixture through variety of methods, right? And we remove unwanted components, we remove harmful components, get a useful component out of it and get a pure sample of the substance. Now, process of removing unwanted components of a mixture to get the desired component is called separation. So, principle of separation depends on the difference in the properties of the component of a mixture. Commonly used method that we discussed in this chapter are hand picking, sieving, winnowing, magnetic separation, sedimentation, decantation, filtration, centrifugation, evaporation, distillation, crystallization and sublimation. So, I hope student this chapter is now clear to you. So, based on the learnings from this chapter, you have to revise and do the exercise in your homework.